In this video, we're going to be going over electron and compound formation. And this is our part 7 video inside of chemistry chapter 1. And specifically today we're going to talk about ionic compounds and also molecular compounds. So let's get started with this video. So the first thing that we're going to talk about is ionic compounds. So ionic compounds are usually formed from a metal reacting with a nonmetal, where the metal transfers a valence electron to the nonmetal, resulting in the formation of cations and anions. So for example, we're going to look at the right here. Here's a picture of sodium and also chloride, and this is the outer shells of both of them. So inside of sodium, the outer valence electron shell has 1, and the outside valence electron of chlorine is 7. So in our previous videos, we talked about if there's 1 valence electron, then you always try to give it because you're trying to get an outer shell that is full. So in this case, sodium would give its last valence electron and give it to chlorine. So once chlorine gets this 1 valence electron, then sodium is going to be full, and also chlorine will be full, because then sodium will have nothing left inside of the valence electron, and chlorine will have 8 in the outer shell. So that means both of them are stable. And once this happens, then sodium will become a positive ion, which means that it's cation, and then chlorine will become negative because there's more electrons compared to the protons. So this is what an ionic compound is. It's where nonmetals react with nonmetals, and then the valence electron gets transferred to the other atoms. So as we said, the sodium atoms transfer electrons to chlorine atoms, creating sodium ions, Na+, and also chlorine ions, which is Cl-. And this bond is for sodium chloride, NaCl, otherwise known as salt. So this is how ionic compounds form. So now we're going to talk about the crystal lattice structure. So the ions in ionic compounds are like sodium chloride, are arranged in regular repeating pattern known as crystal lattice. So as we look at this pictures here, this is how a crystal lattice structure looks like. So once sodium and chloride go together, then they form this type of a crystal lattice structure. For ionic bonds and lattice formation, the strong ionic bond in sodium chloride creates a stable crystal lattice where each sodium ion is surrounded by chlorine ions and vice versa. And for the stability of the lattice, the arrangement of ions in a crystal lattice is highly stable because it allows the ions to achieve a noble gas electron configuration, which is energetically favorable. So this means that since everything has an outer shell that is full, that means the stability of this lattice is really secure because it has the same electron configuration as a noble gas. So now for the formation of molecular compounds. So bonding in nonmetals. So when nonmetals atoms bond, such as carbon and oxygen in combustion of coal, the resulting compound, carbon dioxide, does not display properties associated with ionic compounds, like being composed of ions or forming a crystal lattice. So inside of molecular compounds, it's where of the same nonmetals react and bond together. So this means that there's not going to be any crystal lattice structure as what we saw in the ionic compound, but instead there's going to be a molecular share just as we see here. So we can see in this case, which is CO2, carbon dioxide, there is 2 oxygens and 1 carbon, and they're all connected together in this type of a format, like a molecule. And instead, these also behave as if it's made up of separate groups of atoms that share electrons. So furthermore, on the formation of molecular compounds, for molecules, these group of atoms are known as molecules. So this over here, CO2, is known as a molecule. And a compound that consists of molecules is called a molecular compound. So if there's a compound that consists of different molecules or more than one molecule, then it's called a molecular compound. And also carbon dioxide is an example of molecular compound, and most like compounds are composed of non-metal elements, and it does not consist of ions but covalent bond atoms. So inside of molecular compounds, usually only non-metals go together, and since they're sharing electrons, that means that there's not going to be any ions. And also another word for molecular compounds is covalent bonds. So now we're going to talk more about covalent bonds. So atoms within molecules are joined by covalent bonds, and these bonds are formed when atoms share valence electrons. So for non-metal tendency, so inside of a molecular compound, non-metal atoms tend to gain electrons to complete their valence energy levels. However, because they are non-metals, neither atom readily gives up electrons. When these atoms interact, they are unlikely to transfer electrons, hence a crystal lattice does not form. So this is the reason why crystal lattice does not form inside of covalent bonds, or otherwise known as molecular compounds. And as we can see here, this is another example of how a covalent bond looks like, and this one is water, which is H2O. So there is 2 hydrogens and 1 oxygen, and these are sharing, so then all these end up getting the outermost shell filled, and that's why they are sharing this one electron with the oxygen atom. So this is more about covalent bonds. Now we're going to talk about diatomic and polyatomic molecules. So diatomic molecules, these are molecules composed of only two atoms, and these can be the same or also different elements. So some examples could be gas hydrogen, nitrogen, oxygen, and halogens like fluorine and chlorine. So diatomic molecules are the simplest molecules, and they are very common inside of nature. So diatomic molecules, in summary, basically they're only composed of two atoms, and they can be either different or the same element. So for example, like O2 or H2 and stuff like that. So where there's two atoms and they can be different or same elements, and diatomic molecules are the simplest molecules that are found inside of nature. So furthermore, now we're going to talk about polyatomic molecules. So these are molecules that contain of more than two atoms, and these can be either molecules composed of multiple atoms or the same element, such as the ozone, which is O3, or also more commonly of different elements. For example, we have water, H2O, with 3 atoms, and also there's another example such as carbon dioxide, which is CO2, so there's 3 atoms, and so these are the examples of the simplest polyatomic molecules. So diatomic molecules is where there's 2 atoms, polyatomic molecules is where there's 3, and sometimes it can be the same element. For example, in polyatomic, there can be the ozone, which is O3, but more commonly you're going to find different combinations such as water, carbon dioxide, and there's many different more. And furthermore, also more complex polyatomic molecules form a basis of many chemical substances, including biological molecules like DNA, proteins, and carbohydrates. So now we're going to talk about covalent bonds. So a single covalent bond is a bond which is a pair of shared electrons, one from each atom. And the text mentions chlorine, Cl2, and also water, which is H2O. So here we can see the single covalent bond is where they're attaching just with 2 atoms. And inside of doublet covalent bonds, this is when 2 atoms share 2 pairs of electrons, and they form a double covalent bond, such as carbon dioxide. So if we look here, there's a doublet covalent bond here. They have sharing two different pairs, you can say. And here inside this picture, we can also see that same thing. And for triple covalent bonds occur when 2 atoms share 3 pairs of electrons. Though the text does not provide a specific example, another example we can use is nitrogen gas. So here we can see that a triple covalent bond can share 3 pairs of electrons, as we can see here for this case. So this is the difference between single, double, and triple covalent bonds. And now for a summary of this video. So in chapter 1, we talked about workplace and safety, which is WHMIS. We talked about the atomic theory and the developments of many different over time. We talked about personal applications of chemicals. And in our next chapter, we're going to talk about rules for naming compounds and writing their chemical formulas. So that summarizes everything for this video. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next video.